put that into context, that the AC type is considered fine for resistive loads. So if you had, for instance, an older style
immersion heater.
Yeah, electric shower. I was about to say there, which I ultimately did. So it's been a long day, hasn't it? But with loads of that nature, would be fine. However, if you've got other aspects, other contributors which may contribute DC into the installation, that type AC RCD on that circuit probably isn't sufficient.
Because they won't tolerate any level of DC, will they?
Hello and welcome to another CEF Tech Talking podcast. You join us here in a rather wet and soggy Belfast. However, it doesn't spoilt the view at all, has it, guys?
It's moody, isn't it? Moody across the loch. We're losing it though. The clouds coming in.
Got a bit of atmosphere going on.
Nice.
So yeah, we like it. We've had a fantastic time here at our Tech Talk in Belfast, and Mark Coles has joined us for the Tech Talk. But we thought we'd grab him, not let him get back on his plane just yet, until he talks to us about RCDs. And what on earth is going on.
So Mark, Amendment 2, we pretty much found out that you would like us to use RCDs everywhere. So what is it? Why are we so wedded to RCDs? What's the story there?
My belief is that we're all aware of how reliable they are. You think about RCDs that were installed years and years ago, and we used to be the instruction was test them every 6 months.
Test them every
3 months.
Every 3 months. Every three.
I got that wrong.
Right. Just for you watching on YouTube, you get the opportunity to comment. Just tell us honestly if you did ever test your own RCD.
We went to a factory not so long ago. I won't say where it was, and there was a lady there, and her job was to test the RCDs. She was injecting coke to test the RCDs.
Every single RCD that went out.
And I said to her, at home, do you press the test button? She went, no.
I thought you meant she went around the factory testing the RCD.
No. She's got a little jig thing, and she just puts an RCD in, puts some current in, it trips, and she tests it.
Yeah, all these RCDs, before they go out, they test them all.
Home, she said, no, I don't do that.
They test 100% of RCDs, and her job is the RCD test lady, and she doesn't test her own RCD at home. Can you believe it, Mark? Now, RCDs, you mentioned the Second Amendment there, and the fact that there's a lot about RCDs now, but also the type of RCD. We've gone from the AC for general installations. It now quite clearly says an AC should only be used where there's a fixed load, and it's known that that fixed load does not have any DC characteristics at all. So that's a change in belief around the type of RCD, isn't it?
Well, it's to do with the potential for it to be blinded, though, isn't it? That's the reason for that.
Yeah, so this blinding, how does this blinding work?
Well,
then?
let's just put that into context, that the AC type is considered fine for resistive loads. So if you had, for instance, an older style
immersion heater.
Yeah, electric shower. I was about to say there, which I ultimately did. So it's been a long day, hasn't it? But with loads of that nature, would be fine. However, if you've got other aspects, other contributors which may contribute DC into the installation, that type AC RCD on that circuit probably isn't sufficient.
Because they won't tolerate any level of DC, will they?
But you were going
up through the ranks.
The test instrument with the
we used to do it. I used to use the Robin test meters. I used to use the individuals as they were then, and the RC or the Earth Loop one was the one that used to have the D-lock facility. Now the D-lock, as hopefully some of you listening to this remember, used to inject DC onto the coil of the RCD. That would create blinding, wouldn't it? So that's the blinding we're talking about. That would blind the RCD, so then it wouldn't see if there was a fault. So then that would allow me to then extract the value of Earth Loop through that device
without it tripping. Yeah.
But that was a manufactured fault. Now what we're seeing is, because of a lot of our installations are DC components, it's not manufactured-led anymore. I didn't actually do it for a reason. It's just naturally happening with the connected loads, isn't it? So we could have AC RCDs out there that are affected because of this DC. Now, many of you are thinking, well, what does that mean? What does it look like? It means when the RCD could be called upon, it could not disconnect within the maximum time, or at all. if it's compromised. That's what we're looking at here, aren't we?
Yes.
So that's why you've moved, or the regulations have moved now towards a Type A,
Yes.
which is, it's not. I want to say here, it's going to be great. It's better.
Well, it's 6 milliamps better.
Yes, that's what I was. Yes, that's a great way of doing it. It's 6 milliamps better than its AC counterpart. Yeah. So it will handle 6 milliamps. Now, one thing the listeners shouldn't be doing, Dave, is they shouldn't be thinking, well, what if I got more than 6 milliamps? These devices do not stop that DC, do they?
No, they're not in any way blocking it. They just don't get affected. Their operation is not affected. Up to 6 milliamps, it will tolerate 6 milliamps of DC, and it should still operate in the correct manner. But if you go over the 6 milliamps, chances are it's flooded that coil. It will not respond to an AC fault. So it's become a redundant piece of kit. And then as we go up through the ranks of the RCDs, they become more and more resilient. So you've got a Type F, which will deal with higher frequencies.
Different frequencies coming back.
And then you've got the Type B, which is the one that tends to deal with pretty much anything. It'll pulse DC, it'll take
high frequencies,
DC. It can handle pretty much anything.
And up to 10 milliamps.
Well, yeah, up to 10 milliamps, or even maybe slightly higher, but certainly up to 20 kilohertz of pulse stuff, which is where it has its value as well.
But so on a reg side, on the standard side, Mark, we're seeing definitely the move towards A as a minimum for general installations. But I know B's been mentioned. Is F mentioned much in the regulations at the moment? Because and the reason I'm asking this is we're hearing that manufacturers of boilers, Dave, is it boilers?
Well, it was washing machines and tumble dryers in Germany
are asking
specifying a Type F.
This is why I hesitated there. 7671 doesn't go into any detail at all on F. However, the requirement is that you choose the right equipment for the purpose. So if you have a piece of equipment coming in that's going to bring in is going to be a contributor, and bring in a problem, that therefore the protected device and the design must reflect that and be able to deal with that. So that's where they would come in.
And if the manufacturer specifies it.
And if the manufacturer specifies
it. So I know that there was one manufacturer of gas boilers out there that was saying that theirs must be protected by a Type F. No one could get them. Everyone's going and saying, where do I get these from? How can I get them? Hardly anyone had them. So at that point, they were just thinking, I'm not going to bother. And they were just going with an A-type. An A-type wouldn't be enough, would it, Dave?
Well, you've got the option then to put in an RDCDD, a residual direct current detecting device, which will then pick up, once it gets to the 6 milliamps, it'll then trip the circuit in the same way that, so that it protects anything that could be affected. That's the point. It's not actually protecting the circuit, it's protecting what might be affected by the DC on the circuit, isn't it? Yeah.
So, I mean, I know that that Type AC, Type A, Type F and Type B, here we move towards the Type A. But I know that your chats internationally are starting to pick up on things, aren't they, where people could be moving towards a higher degree. So some of your Scandinavian colleagues that you're working with, they're questioning, are A types going to be okay for the future? I think our installations in the future are going to have more DC in, and we don't know at the minute, probably, do we?
This is what's happening. This is why standards evolve, and this is why the standards that we use most frequently, IB 7671, is updated every now and again, because the standards that it references change too. And if you look, you're looking in Appendix 1 of 7671, the page and pages of all the standards that reference in there, they're all updated. So it goes on.
So are they getting pressure then from? Because I know that it's done collaboratively, isn't it? Are there people in other parts of Europe that are finding problems with Type A's?
Well, not that I've picked up on. But again, an installation's designed to reflect what you want it to do. So if there's a piece of equipment coming in that has a particular characteristic, the protected device should be able to deal with that.
Yeah.
And that's where the standards come from. Now, when issues are highlighted within the different groups, because 7671, of course, is built on lots of different chapters and sections, and those chapters and sections are each based on HDs. In turn, they're based on IEC documents, IEC International Electrotechnical Commission. And within those circles, that's where the discussions start, that someone, a country, for instance, will bring an NP. NP is a new work item proposal, new proposal, and it would say something like, we've established this problem, we believe, our proposal is that this, they call them clauses outside of our country, but the clause should be worded like this, and that's where you see these new requirements filtering through
from countries bringing in
from
fees.
countries. So
Countries
an individual
finding problems. Yeah.
And the Scandinavian countries are pushing quite hard on.
Well,
something.
if you look at what their loads are, they've got massive heat pumps. They've had lots of electric vehicles out there for a lot longer than we have. And they've been working with PV for a lot longer than we have. So if we want to see what we're going to be like in 5 years, we perhaps look to Scandinavia for that model.
I mean, there's some interesting work coming out, isn't there, about the propagation of DC effectively across a larger installation. So it may be affecting remote installations that have A-types that are not. You don't even realise that it's there because it's coming in from a neighbouring property.
Yeah, that's right. So the example could be that you've got a lot of modern kit gone into one particular house, and the next door neighbour, the house is quite close.
Yeah.
And the DC that's being created in this one house can be effectively finding its way through into the other house.
What about blocks of flats? I'm thinking instantly about blocks of flats. Imagine a 5-storey block of flats, and I brought flat number 3 right in the middle, and I've done it all up. I've got loads of LED downlighting. I've got downlighters this. I've got DC this. I've got DC that. Now, my consuming it, I know I'm going to design my system. As you were saying there, you design your system appropriately. So I put in either type A's or type F's or whatever to deal with it. But poor old people in flat number 2 downstairs or flat number 4 upstairs could be dangerous.
We touched on this earlier, and it got me thinking that it might not even be individual flats as such, but you think about the riser that goes up and it feeds individual, it feeds everything on one floor, and you've got the cumulative effects of the DC, and then you've got the landlord's supply for the common parts with RCDs on there. Now, the design wouldn't have ever anticipated, I don't suppose, DC in there, but I suppose you've got the lift.
No, I don't. Well, even the lift, I don't think they're looking at
even
any
a few
DC.
years ago, you wouldn't have been thinking like this, would you?
No.
And designers just wouldn't be thinking like this. And you're now looking at potentially technology which can block DC to stop it propagating its way through a system.
I think that's what we've got to probably look at. So at the minute, we're looking at how to work with the problem. So yes, there's DC current available or in the circuit. Select an appropriate device with that DC present. What I think we're going to try and move towards with manufacturers is some sort of DC filtering.
Yeah.
So you put this on, you install this socket outlet and it's got a DC filter, so that will stop the DC coming out of my tumble dryer onto the installation anyway. Cool, can you imagine? I think we just found something, Dave.
New product.
Here we go.
Sign here.
That all of a sudden, that then resolves the problems, doesn't it?
I mean, you can see how it's quite easy to do technically. It'll be quite a compact, simple device. It's not going to be complex at all.
Yeah.
And it would do the trick. If we started to get them in now, it would alleviate this problem quite dramatically.
I'm off. I'm off to start whittling these away in the garage. But RCDs, the RCDs that we got, when you're doing your installations now, it's vital that you make sure that you're selecting the right one. It's also vital, isn't it, Mark, that we consider what other RCDs are downstream, because upstream, because we've got to know full well that these devices do not block DC, do they?
Can I stop you there?
Yeah.
Upstream, downstream.
Oh, which one's which?
Currents flowing in different directions. We've got battery storage, which is charging, going one way. We've got battery storage going the other way. When it's
but DC, am I right in thinking DC tends to be more of a standing current, doesn't it? So it really doesn't matter what direction the current's flowing. The DC is on the system.
But then there's direction flow with DC.
There is, but it would once it gets in, it would appear all over the place, wouldn't it?
Yeah.
Yes, but it will find a route. It's an electrical circuit, isn't it? It needs to find a way.
So would we have to have bidirectional blocking then? Is that's what I'm saying?
If you have bidirectional blocking, it wouldn't allow anything through.
That's right.
That's called open circuit.
Just turn it off. That's what.
Look, I was in expansive mode there. Sorry.
Yeah, again, this is the problems we're going to have to come across and find solutions for, because we are going to get cars being plugged in that need to be protected with RCDs, but will feed into our installations. Yeah. That's going to happen.
But
we know
also
it's going to happen.
You're going to get a PV array, which will be potentially feeding another way, or a battery installation in the house.
So this is where we're going to need bidirectional devices, because as you alluded to there, my downstream won't be downstream all the time. At certain parts of the day, it could be upstream. Now this, when you're looking at putting RCDs in, you need to really get this right, because there are some devices that quite clearly can't go one side or upstream or downstream of the other. And if you're changing upstream and downstream, I think I'm losing myself here. If I'm changing upstream and downstream, I really am making it really hard.
Am I right? I read somewhere, and I don't know if it was just somebody being creative, that for a while anyway, we're still going to refer to the origin as the origin.
Yes, it'll always be.
So we're not going to flip the origin to the upstream downstream thing. We're just going to say the origin is that, and it's either upstream or downstream of the origin. Would you say that's going to be a convention we'll stick to?
I'm hesitating again.
You've done it. You've stumped him. Well, ask him on sport.
He asked me, well, I'd be equally bad. So the origin is where we would conventionally take a measurement with ZE.
Right.
That's a politician's answer.
No,
Answer the question.
I'm trying to answer. I'll do that in essence. So then, regardless of source of supply, if you're using whatever source of supply you're on at that time,
Oh, right, okay.
So you switch to island mode. Because, of course, you still have to meet the disconnection times.
You would do, yeah.
Now, then it might be that you've got a source of supply that if there's a fault, it might not disconnect. But under 418 in 7671, it would within the disconnection time, it would reduce to 50 volts.
Yeah, the voltage is going to drop. The touch voltage is going to drop to 50 volts again, isn't it?
And that's why some, for instance, some UPSs, for instance, they won't meet the disconnection times because of the high ZS on the circuit because of what's going on inside. But
however,
under fault conditions,
it drops below. It drops below that 50 volt mark.
And I think that's the way we'll be going in the future in the big scheme of things, because there's discussions about conventionally we've got circuit breakers, isolators with the separation distances in there that need to be physically there. But there's discussions about devices. I mean, DC, for instance. there are DC devices that can switch DC in microseconds, and these are semiconductors. And there are discussions, if the technology is proven, why on earth shouldn't it be implemented in standards?
Because a semiconductor, traditionally, you wouldn't put anywhere near that DC to switch it, because you need to guarantee that distance normally. In old way of thinking, you needed to guarantee 4 mil separation distance, but a semiconductor obviously doesn't have that, and that's where
Then you'll need different stages within that circuitry that if that fails and it could create the circuit against something else, is going to prohibit it.
So there's all these things to consider. And if you want to know more about RCDs, there is a fantastic handbook.
The Beamer handbook.
The Beamer handbook that comes out. You guys have helped with this one as well, I believe, haven't you? The Beamer handbook. It talks about the types of RCDs, and it talks about how you can put them in order with each other and existing RCDs in the installation. It's really important you do get your head around these. Not only the changes, but how you design your systems. The Beamer handbook, and it's a technical bulletin. You can get that. It's the RCD handbook, and it is a fantastic. You go to beamer.org, and it's got loads of information there for you, and it's readily available to those who want to go there and have a look.
Yeah, it's free.
Mark,
you can download it.
Thank you very much for your time. It's been absolutely fantastic.
Thank you.
It's been a joy having you here with the Tech Talk and joining us for the technical Q&As and to do the podcast. If you like what you listen to, please subscribe so you don't miss any more future ones that are coming up with Mark and the team. And don't forget, like, share, tell everyone about how good it is, and we'll see you next time on another CF Tech Talking podcast.